everyone, this is Algebra 2, Lesson 1-3, piecewise-defined function. We'll continue with example 5, graphing a step function. This is the last example, so we'll look at a word problem where we can apply what we have learned so far. The shipping cost of items purchased from an online store is dependent on the weight of the items. The table represents shipping cost y based on the weight x. Graph the function. What are the domain and range of the function? What are the maximum and minimum values? So first we want to look at the situation, then we'll graph the function, we'll look at domain and range, and we'll look at maximum and minimum values. So let's look at the weight of the items and shipping cost. We have two variables here that have a relationship, right? So for the weight of items that are from 0 to 2, it would be $5. From 2 to 4, it would be $8. 4 to 6, 11, 6 to 8, 14. So this is a very similar graph from the first example we looked at in the beginning of this lesson, the solve and discuss it question. Right, when we had the two stores selling the guitar strings. Do you remember that? Yeah, so this is when we have something called a step function. The graph of this function looks like the steps of a staircase. This is called a step function since it pairs every input in an interval with the same output value. So let's think about how this graph is possible. So from 0, you're not going to use this shipping company, right? You're not going to have a shipping cost when you don't buy anything. So 0 doesn't make any sense. So anything greater than 0, you have a shipping cost, right? So the weight when it's greater than 0 will start from $5, and then until 2 pounds, it's still the same. And then when it becomes greater than 2, it jumps to $8. So there's no in-between prices. This is what happens when there's no in-between prices, and then it's not a smooth little graph. It's not a linear graph. It jumps, right? It's the same value until it jumps and jumps, okay? So each y value goes with a set interval of x values. So for example, when y is equal to 5, your interval is everything greater than 0, less than or equal to 2. When y is equal to 8, here, if you look at this step, it's the interval for anything that's greater than, 8. Sorry, 8 is right here. The second step is anything that's greater than 2 and less than or equal to 4. So a closed circle means that we're including that price. So when it's exactly 2, then you're still paying $5, okay? When it's greater than 2 and until it's exactly 4, it's $8. So you have a closed circle on the right. So the domain would be any values that are greater than 0 and less than 8 because your table ends here. We're not going to assume that it goes on forever because in real life it doesn't. Okay, there's a weight limit and there's a shipping cost limit. So it ships until the item is 8 pounds. If it's bigger, maybe they use a different shipping method. I don't know. But in this scenario, we can only use weights from 0 to 8, not including 0. The prices range from 5 to 14, but there are no prices in between them. So you're going to list them out, 5, 8, 11, 14. If you say anything that's greater than 5, equal to 5, and less than or equal to 14, it is wrong, okay? This function has a minimum of 5 and maximum of 14. When we talk about minimum and maximum, we're talking about the y values. Okay, so look at the y values, the function values, and compare them to figure out the minimum and the maximum values. Okay. All right, so let's look at try number 5. The table below represents fees for a parking lot. Graph the function. What are the domain and range of the function? What are the maximum and minimum values? So looking at the table, follow the steps we had here and figure out the graph and figure out the domain and range, maximum and minimum value. See if you can do it by yourself, okay? Pause the video and come back when you're ready for answers. Okay, are we ready? Let's look at the table. So the time is an interval, right? That's going to be our domain. Okay, this is our domain. Cost is our range. So when we graph, we're going to see the time here. And then we're going to see, oh, this is in terms of t. We're going to see the cost in dollars. Okay, so from 0 to 1 to 3, not including 0, and up until 3, your cost is $10. And so from here, 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 and we can put the empty circle and then a closed circle here, make it obvious. And then from 3 to 4, 5, 6, we have a cost of 15, not including 3, because when it's exactly 3, we're paying $10. Okay, and then including 6. From 6 to 9, 7, 8, 9, we have 20. And then from 9 to 10, 11, 12, we have 25. Okay, so this should be your graph. What are the domain and range? Domain is when x is greater than 0 and less than equal to 12. Easy. But range, again, be careful not to write the inequality, because for range, you only have a certain amount of range. Your 11 is not included. 14 is not included. Your range is, there are a lot of numbers that are not part of your range. You just have 10, 15, 20, and 25. So you have to list them out. There is no other way. 10, 15, 20, 25. You have to write them down, okay? And then the minimum would be when your function value, the value of your function is the minimum. So it's 10, right? Oh, wait. I need to put empty circle here where it's 0. Okay, minimum is 10. And the maximum is 25. When we're just talking about the features of the graph, we don't have to write the units. But when we're talking about how much would we have to pay for the shipping if it's this time, right? So if the question has a context, then you need to write your answer with units. So make sure you know how to differentiate those. All right, that was example 5. And we're done with our lesson. Let's summarize our concept. Piecewise defined functions. We looked at different types of piecewise defined functions. And a piecewise function has different rules for different parts of its domain. Part of piecewise function, we looked at absolute value, right? Absolute value function is also a part of piecewise defined function. Another type, step functions. Okay, so there are a lot of different kinds of piecewise defined functions, and they could look very odd, but as long as your domain has one set of output, one value of output, then it is a function. Okay, so your function notation will look something like this, and a graph may look like this. All right, that was lesson 1-3, piecewise defined functions. I'll see you in the next video and then talking about the next lesson. Bye, guys.